Alright guys, this is the last set of notes for this unit on quadratics. Hopefully you've been bearing with me through all these videos that I've had to make for you. Last section is on maximum height. So we're thinking about the maximum height of a parabola. So first, to just kind of get you thinking about this, it says if you threw a ball up in the air, draw the path it would take. The ball would start on the ground and end on the ground. So here's the picture of the ball. If we threw this up in the air, it would go up in the air and then it would come back down to the ground. Now this maximum point that it's going to hit is your maximum height. Another way to describe that point is the vertex of that parabola. Hopefully I can fit all the graph on here. I cut some of my graph off, but that's okay. It says find the coordinates of the maximum point on the graph to the equation, round your answer to the nearest hundredth. So I am going to kind of just sketch a quick picture of what this graph looks like. All you need to do is plug this into your y equals and get your table of points. I'm going to copy that down now. And plot those points. And it looks like I'm not going to be able to fit that last point to -9, but that's okay. It's going to look something like this. Now it's kind of hard to tell looking at this graph what the maximum height is, what that vertex is, because it's not a very symmetrical parabola. So what we're going to do is use our calculator to find that vertex. We've done this before in class. You're going to use these steps here. You're just going to be on the picture of your graph. You're going to hit second calc max. And again, you're trying to find this vertex point up here. So it's going to, again, on your calculator, ask you to do left bound, right bound guess. Just make sure for left bound, your cursor is just to the left of your vertex. Right bound, your cursor is just to the right of your vertex. And then hit enter twice for guess. Once you do that, you should be seeing that your max, if we round to the nearest hundredth, is at -0.75, comma 6.12. Again, I'm sorry I don't have a calculator screen to put in this video for you. But we did do this process of using the maximum function on your calculator before in class. So this first example says, using the graph to the right, it shows the height h and feet of a small rocket t seconds after its launch. The path of the rocket is given by the equation -16t squared plus 128t. How long is the rocket in the air? So think about this if this were kind of like a visual picture. It's going to start on the ground here. It's going to launch up into the air and then hit back on the ground here. So it looks like it's in the air for 8 seconds. Excuse me. What's the greatest height that the rocket reaches? So it's asking for the max height. That's going to be this point here. Looks like each of these is 10. Each of these hash marks are it's going up by units of 10. So here's 250 here. It's one above that, so it looks like it reaches 260. About how high is the rocket after 1 second? So looking at an x value of 1, looks like it's at this point here, so it's at 100 feet. Number 4, after 2 seconds, how high is the rocket? So here's 2 seconds. If I follow that part of the graph up, we're at this point right here, which looks to be 190. And then it says, at that point, is the rocket going up or down? Again, thinking about the path of this rocket in terms of this graph, this is still at the point at which the rocket is going up into the air. So we're going to say up here. After 6 seconds, so we're looking here. How high is the rocket? That's this point here. It is again at 190 feet. But at this point, the rocket has hit its maximum height, which is this point here, and now it's falling back down to the ground, so the rocket is going down here. Number 6 says, do you think the rocket is traveling faster from 0 to 1 seconds or 3 to 4 seconds? And explain your answer. This is asking about the slope of the line. The bigger the slope is, the faster that this rocket is traveling. So we can actually find the slope between 0 and 1, find the slope between 3 and 4, and then kind of compare those to see which one is going faster. So if we're going to go from 0 to 1, remember the way we find slope is the change in the y over the change in the x. This is kind of throwing it back to sort of the beginning of the year. When we did a couple lessons on slope. Okay, so y values from 0 to 1 second. So at 0, the y value is 0, and at 1 second, the y value is 100. And remember that little triangle, which is called delta, means the change. So we're going to subtract the y value from 0 minus the y value from 100. And then your change in x is just going to be that 0 to 1. So times 0 minus times 1. If we simplify those and divide it, we get the rate of change here to be 100. If we want to do the same thing from 3 to 4 seconds, again using change in y over change in x. All right, y value at 3 seconds looks like it's at 240. Again, just go to 3 seconds and follow that graph up to where that point is. Y value at 4 seconds, that's when we're at our maximum height at 260. And then our change in x is just the 3 seconds minus the 4 seconds. If we simplify that fraction, we do get 20. So since the rate of change was 100 at 0 to 1 and 20 at 3 to 4, 0 to 1 is going to have the faster travel time, or traveling speed, I should say, because it has a higher rate of change. So our answer, somewhere where I have room, is going to be 0 to 1 because it has higher rate of change. And it kind of makes sense, like logically in real life. It's going to have a faster speed as it goes, kind of shoots up from the ground. Once you get up to where like 3 and 4 seconds is, that's where it's kind of going to slow down at its maximum height and then start to fall down to the ground. Okay, now it says using the equation, find the exact value of the height of the rocket after 2 seconds. Remember, t is representing our time here, so it looks like we have to plug in 2 for t into the equation that they give us, which is negative 16t squared plus 128t. So anywhere you see a t, you're just plugging in 2. You can type the whole thing into your calculator exactly how you see it. So negative 16 times 2 squared plus 128 times 2. I should be getting 176 feet. Just going to scroll to the next page to get to number 8. Number 8 says, what is the domain of the graph? You have to remember that domain means your x values. Okay, so your x values in this case, if we go back to the picture of the graph, is your time. Okay, so the only x values that are going to be recorded here is the only time from when the rocket starts on the ground to when it hits the ground after it kind of lands after being in the air. So your domain here is going to be 0 to 8. And this is also kind of throwing it back to talking about domain and range of certain functions, where we use parentheses for values that are not included in the domain or range, and we use brackets to show when it is included in the domain or range. So 0 and 8 are included because it's when it starts on the ground and then when it hits the ground after being in the air. Now range, remember, is y values. So it's asking what y values are included on this graph. Well, it starts at 0 because it starts at a height of 0 on the ground, and it hits its maximum height at 260 feet. And those values, again, are going to be included in our range, our y values, so from 0 to 260. Again, we're using brackets because they are included. Express the interval over which the graph is increasing. So if we go back to this picture of the graph, it's asking when is the rocket going up, okay? It starts at 0 on the ground, and they're asking for what time interval, so talking about seconds. So from 0 to when it hits its maximum height, that's at 4 seconds. So it's definitely from 0 to 4, but then we need to ask ourselves, is 0 and 4 included in this time interval or this range? Think about it. At 0, is the rocket actually increasing? No, it's actually at a standstill, right? So 0 is not going to be included, which means we're going to use a parenthesis there. And then at 4 seconds, when it hits that maximum height, at that instant, is it still increasing? The answer is no. It's actually going to stop in midair, and then it's going to start decreasing. So we are going to say from 0 to 4, meaning 0 to 4 seconds, but we're going to use parentheses here to show that those two values are not included in the points at which it is increasing. Number 11 says state the interval that it's decreasing. So again, it's decreasing from the point when it hits its max height to where it hits the ground, so from 4 to 8 seconds. And just like before, we are not going to include 4 or 8 because that's those are 2 points at which it's actually just kind of at a standstill, whether it's hitting its max point, its max height in the air, or it's now on the ground at 8 seconds. So we're going to use parentheses there as well. Oops. All right, example 2 says, a ball is thrown in the air. The path of the ball is represented by the equation, negative t squared plus 8t. Graph the equation over the line 0 to 8 on the accompanying grid. So this is saying your time is going to go from 0 to 8. What we can do, guys, is we can just type this into our calculator, negative t squared plus 8t, into your y equals, except you're not going to be using t, just use x as your variable. So you can do that on your calculator and then plot those points. I'm going to start plotting mine. graph is hard to draw on this tiny piece of graph paper. Let's see, can I zoom in? Ooh, perfect. Oops. All right, so hopefully that's accurate enough. So that's the path that the ball is going to take from 0 to 8 seconds. Next question, part A, says, what is the maximum height of the ball? That's going to be this point here. When they're asking for the maximum height, they just want the y value of that. So remember, y is representing how high or low something is going. And it looks like that's at 16 feet. What is the amount of time that the ball is above 7 meters? So 7 is here. Right, 7 is right here. So the time that it's above 7 is going to be 1, 2, 3, 4, 5 seconds. That's going to be, oops, as I can't spell. That's going to be this point, 2, 3, 4, and 5. Here and here, we're actually just at 7. So we don't want to count those as above 7, obviously. All right, number 3, a swim team member performs a dive from a 14-foot high springboard. The parabola shows the path of the dive. What's the axis of symmetry? Remember, the axis of symmetry goes through the vertex. So that's going to be this point here. And it's the x value of that vertex. It's this vertical line that goes through the vertex. And it looks like that is at x equals 3. Okay, right between 2 and 4. Part B says find f of 6. So they want to know where is the function at an x value of 6. If we follow that up to where the function is, it's about right here. Which is about, we'll say 14 feet. Okay, halfway between 12 and 16 is about 14. Okay, so these questions, again, are just getting you to look at these pictures of the graphs of these parabolas, thinking about what the maximum height means, and finding different things like the axis of symmetry or the value at a certain x value. I think this is, nope, not the last one. Melissa graphed the equation y equals x squared, and Dave graphed the equation y equals negative 3x squared on the same coordinate grid. What's the relationship between the graphs that Melissa and Dave drew? What you can do is just type each of these into your y equals at the same time. So one goes in your y1, the other goes in your y2. And then just hit the graph button and kind of compare what they look like. So if you'd like to pause the video, get that into your calculator, and see if you can come up with a comparison, and then play the video when you want the answer. So it looks like Dave's, which is the second one, is narrower. Oops. Is narrower. This is really hard to write on. Narrower. And it's also reflected over the x-axis. Which means it's just kind of flipped down to the bottom of over the x-axis. Okay, some word problems about max height. After t seconds, a ball is tossed in the air from the ground level, reaches a height of h feet given by the function h of t equals 144t minus 16t squared. What's the height of the ball after 3 seconds? You could put this in your calculator, graph it, and kind of see if you can find where the graph is at 3 seconds. Another way to do this is just realize that seconds is being represented by t here. So if we take this function and plug in 3 for t and evaluate that, that'll tell us where the ball is at 3 seconds. So go ahead and type this into your calculator. You should be getting 288 feet. Letter B, what's the max height of the ball? This is where you're going to have to use your calculator. And again, I apologize, I don't have a calculator screen to show you on here. You're just going to put the function in your y equals. You are probably going to have to zoom out. So you're going to use that zoom button and choose the option that says zoom out so you can see the vertex of it. And then you can do second trace and choose maximum. It's going to take you through the left bound, right bound, enter, and you should be getting 324 feet. After how many seconds will the ball hit the ground before the rebound? Couple different ways you can look at this. You can look at the graph and see when is it going to touch that x-axis again, or you could look at your table of values. So hit second graph on your calculator to see where do we have a y value of 0. This is going to be after 9 seconds. This is a long set of notes. All right, number 2, a rocket carrying fireworks is launched from a hill 80 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake will be given by the function negative 16t squared plus 64t plus 80. What's the height of the rocket after 1.5 seconds? Again, t is representing our time here in seconds, so we're just going to plug in 1.5 for t. So it's going to say negative 16 times 1.5 squared plus 64 times 1.5 plus 80. Type that whole thing into your calculator and you will get 140 feet. So after 1.5 seconds, it's going to be 140 feet high. What's the maximum height reached by the rocket? Again, this is something you'll find in your calculator using that second trace maximum function. It is at 144 feet. After how many seconds after it's launched will the rocket hit the lake? You're looking again for where it's going to hit that that x-axis, or again looking into your table to see where the y value is going to be 0, where its height is 0. It's going to be after 5 seconds. Okay, number 3, a rock is thrown from the top of a building. The distance in feet between the rock and the ground t seconds after it's thrown is given by d of t equals negative 16t squared minus 4t plus 382. How long after the rocket is thrown is it 370 feet from the ground? So this is asking when is its height, which is represented by d of t, when is that going to be equal to 370? So we're going to plug 370 in for d of t. Everything else is going to stay the same. Now, the easiest way to answer this question is to get this into standard quadratic form and then use one of the ways we've learned to solve a quadratic to find the solutions. Remember, we want one side of this to be able to solve it. We want this left side to say 0. So I'm going to subtract 370 over, and I can subtract that right from the 382. 382 minus 370 gives us positive 12. Now that I have this in standard quadratic form, I'm not going to try and factor this. I'm not going to try completing the square. What I'm going to do is actually use quadratic formula here. I can really easily find my a, b, and c values. A is going to be negative 16, B is going to be negative 4, C is going to be positive 12, and plug that into the quadratic formula. If you need to see the quadratic formula again, that is on a couple of the sets of notes we've done. Again, don't feel like you have to memorize it. It's given to you on your exam. So it's going to be x equals negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. Evaluate everything under the square root symbol. So 4 plus or minus, that evaluates to be 784. And then denominator, we get negative 32. 784 actually is a perfect square. If you take the square root of it, it is 28. So this is going to be 4 plus or minus 28 divided by negative 32. Okay, so then we just want to split this up, one getting the plus, one getting the minus. So x equals 4 plus 28 divided by negative 32. And x equals 4 minus 28 divided by negative 32. Plug each of those into your calculator. This first one, you're going to notice we get negative 1. Second one, we're going to get 0.75. Now, this is seeming a little weird because we're getting two solutions. They just want to know how long after the rock is thrown. Is it 370 feet from the ground? We can't have two options here. We are going to eliminate the x equals negative 1 because what we're finding right now, the solutions is these two solutions are representing time after the rock is being thrown. You cannot have a negative version of time, so we're going to completely kind of just disregard that answer of negative 1, and it looks like it's going to be 370 feet from the ground after 0.75 seconds. Okay, next we just have some Common Core questions about maximum height. So they give us the graph, and then they give us another function, negative 1/2 x squared plus 4x plus 3. They want to know which one has the larger maximum. We can really easily tell where the maximum is on the picture of this graph. It's going to be at positive 6. We can find the maximum of this function that they give us by plugging it into our calculator using the second trace max, left bound, right bound, enter. If you do that, you will find the max to be at 11. So it says determine which has the larger one, obviously g of x. And then it says justify. We can just say because the max is at 11 and f of x has a max at 6. Okay, you don't have to explain how you know that 11 is greater than 6. That is a perfectly fine justification for that. I know I'm going kind of quick through this video, so if you need to pause, you need to rewind and rewatch something, please make sure you do that. I'm just trying to not make this video super duper long. Number 2, a ball is thrown into the air from the edge of a 40-foot high cliff. So here's where it's starting on that cliff. So that it eventually lands on the ground. The graph below shows the height of the ball from the ground after X seconds. For which interval is the height always decreasing? So this ball is being thrown up into the air. It's hitting its maximum, looks like to be about here. And then once it hits its maximum, it's falling back down to the ground. So it looks like from here to here is where it's decreasing. Okay, so they're asking the interval in terms of the seconds. So it looks like it's starting here at 2.5, and then it's decreasing until 5.5, which is choice 3. So that's saying every x value from 2.5 to 5.5. Which quadratic has the largest maximum? For choice 1 and choice 3, you're going to want to put these in your calculator, graph them, and use that second trace calc maximum function to find where the maximum point is at. Again, I don't have a calculator screen on here to do that for you, but you can try that out. The first one, the max is at 6.25. For choice 3, it's at around 11.2. Okay, number 2, looking at the y values, which is these values here, your maximum is going to be somewhere in this range here. So it's going to be a little bit higher than 9, so I'm just going to note that here. Max is a bit higher than 9. The reason it wouldn't be showing up on this table is it's probably at a decimal point value, and obviously this table is not showing any decimal points. Max here for choice 4 is going to be at its vertex, which looks to be at about 4.5. Okay, they want the one that's the largest, so it's looking like choice 3 at 11.2 is going to be the highest maximum. All right, finally, we're on the last one. When an apple is dropped from a tower 256 feet high, the function negative 16t squared plus 256 models the height of the apple in feet after t seconds. Determine algebraically, which means you cannot use your calculator. You need to show some sort of work. The number of seconds it takes the apple to hit the ground. If h of t here is representing its height, when the apple hits the ground, its height is going to be at 0. So I'm just going to note that here, when it hits the ground, height is equal to 0. We'll just say height equals 0. So what we want to do is just plug in 0 for h of t. So our function becomes 0 equals negative 16t squared plus 256. And then we just need to solve for t, so get t by itself. First thing I want to move is the 256 by subtracting it. Negative 256 equals negative 16t squared. Next step to get t by itself is I need to get rid of the negative 16. Since negative 16 is being multiplied by t squared, to move it, I need to do the opposite and divide it. So negative 256 divided by negative 16 gives us 16 equals t squared. And then to get t alone, so we need to get rid of that squared symbol, is we need to do the opposite and take the square root. So we're going to go ahead and take the square root of both sides of this. Square root of 16. So we could say square root of 16 is either positive 4 or negative 4, but since we're talking about time here, we know that time cannot be negative, so we're just going to use positive 4 as our value there. So our answer is 4 seconds. Okay, there is no homework attached to this section because we went through so many examples together. And like I said before, just make sure to rewind, rewatch, whatever you need.